Okay, in this video we are going to solve exponential equations using another method. This time we're going to apply properties of logarithms. So the last video we used the properties of exponents to solve these types of problems. This time we're using another method, and so let's begin. So these are the four problems that we will solve together. But before we solve them, it's important to know what property are we going to use. We're going to use the inverse properties of logarithms, and there's really two of them. Log base b of b raised to x is equal to x. So all of this got canceled. B raised to log base b of x, all of this gets canceled and you get x. And this works whenever the number is bigger than 0 and the b value cannot be 1. I guess as a side note to help you kind of remember what we're doing, inverse operations is that it reverses the effect of another operation. And so this is called the inverse property of logarithm because it kind of, it cancels something out. It cancels all of this out. It cancels all of this out. And so let's get started. Okay, this is our first problem, and our first step is still very much the same. We're going to divide by 3, divide by 3. We want to get the exponent piece by itself. So we're going to get 4 raised to x is equal to. Now, if you can use a calculator, feel free. If not, we can do old-fashioned division, not a problem. So how many times does 3 go into 19? Well, 6, because 3 times 6 is 18. We subtract it. 19 minus 18 is 1. Bring down the 2, so you get 12. How many times does 3 go into 12? 4 times. So 192 divided by 3 is 64. Now we're going to apply the whole inverse properties of logs. So in order to cancel this 4 out and to apply the inverse properties of logs, what we could do is put a log base 4 on both sides. If you do it on one side, you have to do it on the other side. So we just put it here, so we need to put it by the 64. So log base 4 of 64. And by doing this, this whole piece gets canceled and you just get your x. So we get x is equal to log base 4 of 64. Now we're not done yet. We can actually modify this to get you a form similar to this. I'll show you what I mean by that. So we can change it to log base 4 of, instead of 64, you could say 4 raised to 3, because 4 times 4 is 16, 16 times 4 is 64. And we might notice something kind of special. Log base b of b raised to x, this whole piece gets canceled, and you just get the exponent. So again, this whole piece gets canceled, you just get the exponent, so x is equal to 3. So our final answer is x is equal to 3. Okay, this will be our second problem. I recommend pausing the video and attempting it. So we have 4 times 5 raised to x, so we can get rid of the 4 in front of the 5 raised to x by dividing by 4, dividing by 4. We get 5 raised to x is equal to 100 divided by 4 is 25. Now again, we're using this whole properties of logarithms, so we're going to put a log base 5 on both sides. And so if you do it on the left-hand side, you have to also put it on the right-hand side. And a log base 5 of 5 raised to x is like this piece right here. So this whole piece gets canceled. You just get your exponent, just x is equal to log base 5. To kind of speed it up a little bit, instead of saying 25, you could say 5 times 5 is 25, so 5 squared. And now we can do this log property again. So this whole piece gets canceled, but the 2, because log base 5 of 5 raised to 2 is just like this, log base b of b raised to x. You just get the exponent, so just the 2. And so our final answer is 2. Okay, our third problem, a little bit more work. We want to first get rid of the plus 46. You can subtract 46 on both sides. And we can do the old-fashioned subtraction. Or if you want, use a calculator. So 1 minus 6 gives you a negative number, so we got to borrow some from the 2. So 2 changes to a 1. The 1 changes to 11. 11 minus 6 is 5. Change the 9 to an 8. Change the 1 to 11. 11 minus 4 would give us 7, and we have 875. So we get 7 times 5 raised to x is equal to 875. So now we have 7 times 5 raised to x, so the opposite of multiplication is division, so divide by 7, divide by 7. Again, we can do the old-fashioned division, or if you want to use a calculator, how many times does 7 go into 8? It goes 1 time, so 7 times 1 is 7, so we're going to subtract it, we get 1. Bring down this 7, so we have 17. How many times does 7 go into 17? Twice, you get 14. And 17 minus 14 is 3. Bring down the 5, you get 35. How many times does 7 go into 35? It goes 5 times. So we get 5 raised to x is equal to 125. Again, in this video, we're using this log property, so we're going to put log base 5 of 5 raised to x on both the left and the right-hand side. If you do it on one side, you have to also put it on the right-hand side. By doing this, all of this gets canceled but the x, so we get x is equal to log base 5 of 5 raised to 3. Because 5 raised to 3 is 5 times 5 is 25, and 25 times 5 is 125. But same idea, all of this gets canceled but the 3, so our x value is going to be 3. Okay, our last problem, if you want, feel free to pause the video. So we have a plus 37, we want to get rid of it, so we subtract 37 on both sides. We can do the old-fashioned subtraction. So we can change this 1 to a 0, change the 3 to a 13. 13 minus 7 is 6. Change the 6 to a 5, change the 0 to a 10. 10 minus 3 is 7. You have 576. So we get 9 times 4 raised to x is equal to 576. So you're saying 9 times 4 raised to x, the opposite multiplication is division, so we're going to divide by 9, divide by 9. We get 4 raised to x is equal to, we can do the old-fashioned division. Let's divide. How many times does 9 go into 57? Well, 9 times 6 is 54, so we put a 54. We're going to subtract it, we get 3. Bring down the 6, you get 36. 9 times what gives you 36? 4. So we get 64. Today's video is using the log property, so we're going to use log base 4 on both sides. To apply that inverse property, if you do it on one side, you have to also put it on the right-hand side. So again, log base 4 of 4 raised to x, all this gets canceled. You just get the x is equal to log base 4. Instead of having 64, you could change it to 4 raised to 3 because 4 times 4 is 16. 16 times 4 is 64. And again, we can cancel all of this. So our x value is 3. And that's all we need to do to solve exponential equations using logarithms.